We are offering freelance services in data analytics, machine learning, audio engineering, and web development. Feel free to check out our website, services section, to see our portfolio and what we can do, and book a call with us to discuss your data challenges. We'll be happy to help you out. This is Data for Future. Enjoy this episode. Hello, everyone. Good morning or good evening, depending on the time where you're listening. Today, I have a great pleasure of welcoming someone from the company that's so impactful in the place where we are, that's called Holaluz. For the ones that do not know the company, this is a provider of renewable energy here in Barcelona. And today we have Pablo Rosado with us, who is senior data scientist at Holaluz. And I'm very excited to know more about the company and how they deal with data problems, what kind of data problems they have. So yeah, a warm welcome to you, Pablo. It's nice to have you here.
Thank you very much. And thank you for inviting me. I like the podcast very much. So I'm happy to be here.
Great, thanks. All right, so why don't you start by introducing yourself a little bit? Maybe just let us know what kind of things you do at Holaluz, what it means to be a senior data scientist there.
Yeah, so I'm an astrophysicist. I used to be, at least. I studied physics and I did a PhD in astrophysics in gravitational waves and a few postdocs. So I used to be 100% stereotypical academic, I guess. And then at some point, I moved to the industry. I started doing data science. Initially, I was working in a consultancy company here in Barcelona. And then since I moved to Spain, I actually was interested in working in Holaluz. I actually found it a very interesting place to work for their values, for what they do. I think it's a very useful, positive work to do in Spain in particular. We can talk about that later on why I think that's important in this country. And yeah, since I started working there in 2018, we have been doing several different things. I think what companies in the energy sector need the most, and not only there, but also in general, many companies, they usually do need more data engineering than data scientists. And by saying that, probably I am saying something bad about data scientists, and that's by no means my intention. I'm a data scientist, so I don't want to say that our work is not useful, but I think there is a trend to hire a lot of data scientists while not filling the gap of data engineering in a company. That happens in particularly in the energy sector because there is hell with data. Like, the system is really ugly and dirty. I will tell you a bit more about that if you want. And I think data scientists usually benefit a lot from having a data engineer by their side. So I think that's a good thing. And also, I think that it's good for data scientists to learn more about data engineering. Right? I think it's something that should be part of our skill set, to know how to develop data pipelines and put them in production. Like, when you do courses online about data science, you learn about training neural networks and doing a lot of amazing things with amazing data. But in reality, you often don't have amazing data. You have really crappy data that changes, that is not consistent. It cannot be easily validated because the data sources change without letting you know. Things like that. All sort of things can go wrong at any time. Yeah. In particular, not only the renewable energy sector, in general, in the energy sector, and at least in this country, it's really challenging, which is good and bad. It's bad because it doesn't let you easily do all these cool things that all the data scientists are excited about, like, training neural networks, doing a lot of deep learning things, trying the latest tool on this and that. Maybe it's a massive overkill to try to do these things when your data is not so informative, and the models that you need to put this in production and make it useful they don't need to be so complex to get the problem solved, right? So that's just a sort of disclaimer. If you want to work in the energy sector, you have to be aware that as a data scientist, maybe you are not going to do the most cutting edge deep learning thing. But on the other side, as a positive thing, I believe, is that you will really confront problems of how to develop a pipeline using really bad data and how to manipulate really bad data, how to clean it, how to deal with issues or, like, for example, the data being not what it was meant to be, doing all sort of validations, testing, finding biases in your models, all these kind of things that are sort of neglected when you learn about data science, at least in the usual online courses or when you watch videos, when you read blogs. It's usually all about the really fancy part of it. But this part that is possibly more connected to data engineering is very important. And in Holaluz, part of what we do is that, like dealing with messy data, trying to develop pipelines that are robust, that you have good visualizations of how things are going, how your machine learning models are performing. All these sort of things are sort of the main part of my job.
Yeah.
We have also done some sort of cool NLP things, like some deep learning, some natural language processing, for example, classifying the communications that, like when our clients contact us by email, for example, we have some pipelines to classify them depending on their urgency or depending on the type of communication it is. We have done some of that. But yeah, most of the job is basically to predict energy consumption so that we can buy the energy that we need, no more, nor less, and so that we can also charge our clients for the energy that they are going to use. And maybe you are wondering, why don't you just charge them for the amount of energy that they use? Well, actually, we don't have that possibility. Like, the data that comes to us usually is not set on stone. It's like it can change. I'm not saying that the data that we have to predict for the future, we also have to do that, but also we have to predict for things that have happened in the past. We have to predict what our clients have consumed in terms of energy. Why? Because the data always comes delayed. It comes late. Yeah. Like, it can come like a month later. It can come 2 months later, and it can change. Like the data that the distributors tell us today, it can be different in a month from now. So we have to keep track of all the data points that we receive and have a timestamp to know when that data point arrived. Because tomorrow, it may be different. For a certain client, what we believe they were using, if we believe that they were using this much energy, tomorrow, that could be different. So that makes everything really challenging. And you could see it as a positive or as a negative, because obviously, it as I said before, it doesn't let you do really amazing models because the data can change. So then the model will also change. You will have to adapt it every time. So you want more quick and adaptive models rather than one that needs to train for a very long time with a lot of data. So yeah, but on the positive side, it really is a challenging problem to solve, and you have to really learn a lot about how to deal with databases, about scalability, how to productionalize machine learning models quickly and easily, how to track their performance, and all these kind of things.
Definitely.
So, yeah, those are the kinds of things that I deal with every day in Holaluz.
Yeah.
I don't know if that's exciting or not.
It is, and I feel it so much, what you say about the complexity and also the stuff where there's so much hype about it right now, like deep learning. Me personally, I guess there are many people like me who entered the field of data science with this notion of, I want to do AI stuff. I want to build the neural nets. I want to have this cutting edge accuracy. And although it's true, and actually it's also very empowering how some courses like the Fast AI, not sure if you know about that, is making it so accessible for everyone. Things like deep learning. You don't need to know lots of math. You don't need to know lots of coding experience. But nobody tells you there that actually, when you come into the real world to solve real problems, probably you're not gonna be dealing with the problems with deep learning. It's like this is just my life right now. I entered a new job as data scientist, and I was so excited about building super complicated models. And actually now I'm starting to realize, oh, I have so much gaps in my skills in SQL, for example, or how to build a code in a way that it's written to be, like you say, scalable, right? That the model can be expanded, maybe new features can be added without destroying anything that was written before. And no one, at least in my case, no one taught me this in the online courses. Maybe they do in the university. Yeah, like data wrangling and doing basic manipulations, cleaning data is very important. And in case of Holaluz, how many people are you in the team of data scientists? How
right
developed
now,
is this?
we are changing all the time because we are growing very, very quickly. So I have been in many different groups of different sizes. Right now, we are basically 4 in our team. We are hiring another person soon. But I've been in slightly bigger groups, but max 10 people. But we also have other data analysts / data scientists / data engineers in other groups. We have, for example, a business intelligence group. We have, some other teams that are more working with marketing data, or we have like different sort of departments. We don't like to call them departments, but we have different groups where we have data scientists there. So it's not like we have a unified team of all the data, human power to solve all the problems in one group, but rather we have it sort of spread. We have the data, so to say, data knowledge spread in the company. But in my team right now, we are like 4 or 5 people.
Oh wow, so young. I guess maybe the deep learning part still comes, but just in the in some distant future, or maybe not so distant. Who knows?
No, I mean we have done some deep learning actually, but I think I think what you just said right now is really right. Like somehow you can get disappointed in a real job when you realize that how can I use these really complex models? I think there is room for that. You can try, but what I have realized in many real case scenarios is that the most important thing is to have a robust data pipeline and a robust model selection pipeline. Then whatever you input, whatever the ingredients of the predicting model are, that's going to be part of the you have to decide which one is going to be better depending on a bunch of metrics, right? So for example, you may try with a simple logistic regression to do some binary classification or whatever. You can try then, if it performs decently well, you can try maybe with something a bit more sophisticated. You can try with decision trees, extreme gradient boosting, whatever. And you see that maybe the performance is a bit better. And then you can try with neural networks if you want. And I have tried to solve certain problems. We have done it. For example, in this NLP project that I told you about, we are using deep learning. But the performance may be just a tiny bit better, if anything. Yeah. Whereas when you do a little bit of feature engineering and just a bit of hyperparameter tuning, doing proper validation and making sure that you are not overfitting or doing something that will not generalize well in production. Yeah, sometimes you just realize that this new super complex model is going to take much longer when it's in production, and it may not be feasible because you have to, for example, you have to retrain your model very often, and that's going to take much longer if it's a much more complex model, whereas a simpler model performs almost as good. And it yields pretty much the same result. And also, it's important to be able to interpret it a little bit better. Yeah, you may have you can measure feature importance on certain models, and some others is kind of more obscure, and you just accepting whatever the model says without knowing why. So I think interpretability is a very important aspect to take into account. And therefore, the simpler models are usually just better.
Exactly. Yeah. What are the other lessons that you have learned in terms of data science? Very practical things maybe that could help other people in similar situations?
I think something you said before was also very important, which is that you have to deal a lot with databases, like dealing with, being more comfortable doing Postgres queries, for example. Like that's something that you have to do every day. And you can do most things just in Python or using pandas or whatever you like to use, or in R. But it's usually very, very useful to have a bit of knowledge on database management and knowing why something is taking much longer, or if some job is stuck, why, or how to deal with that. These kind of things that are, less attached to the job of a data scientist for whatever reason. But that's what you end up doing most of the time.
Yeah.
What else? Cleaning data, doing basic analytics. It's something that, there is a job called data analyst, which is supposed to be something different from data scientist, but you have to analyze a lot of problems. You have to come up with simple solutions, or a few numbers, a few graphs, just to take decisions every day. So every business decision that you take is based on a prediction, and a prediction is, or can be, based on a machine learning model, or it doesn't even need to be a machine learning model, but it's some sort of algorithm that gives some information, yields an answer, right? So every decision is, in a way, a prediction. It doesn't need to be machine learning. It doesn't need to be deep learning. It could be a statistical product. It could be a Bayesian algorithm. You're just making some inference based on some prior knowledge. It doesn't need to be the fanciest thing in the world. It could be a rule-based algorithm. But in the end, every decision that your company is taking should be, to a great extent, based on data. So that's what makes a company data-driven. Not only that we have the most amazing data pipelines or algorithms or whatever fancy thing you want to mention, it's more that the decisions that are taken in the company are based on predictions, based on data, or simple analysis based on data, because that's what we mostly have. The fact that we can do data science is because we have the data to enable it. I'm not a data scientist because I particularly love data. I love science, but data is the means to do science.
Yeah.
So, if we have it and we have to take some decision, we should work with that. We should analyze it and come up with the best solution, or one solution that solves the problem well enough. And that's part of the job as well. Just taking quick decisions based on the data that you have, which may be wrong because your data were wrong, but it's part of it. You learn from it.
Definitely. No, absolutely. And also, while this is so true also what you say, that sometimes it doesn't even have to be a machine learning model. It can be a simple statistical model that just has 3 features, and it can perform maybe not as good as a neural net, but it might be very close to it, but can be built in so much less time, so much easier to operate. And in the end of the day, these are actually the things that have the biggest impact, right? They don't have to be very complicated and very advanced, but still, if you know how to use them in the proper way, I guess this is the real practical experience that you start to gain, right? When you enter the business world and start to see, this is how it works. So one of the things that I wanted to ask you, because our paths are like the opposite. So in my case, I decided not to go to the university, not to follow the traditional education, and to go straight into learning with online courses, just coding as much as I can, developing projects, and learning theory online, and doing practical stuff on my own. Or there are also a couple of amazing organizations where you can find projects to participate. For you, though, it's exactly the opposite. So you come from a very theoretical, very research-driven background, astrophysics, Like, wow. And then you enter from there into the business world and enter a company as a data scientist. So I'm curious about what were the difficulties that you had to encounter while making this transition?
Yeah, that's a great topic. That's a topic that I started writing a little bit about it recently. I started blogging a little bit about the topic of how to transition from academia to industry. Not necessarily only for data science, but that's what I know about. So that's mainly the what I'm writing about. Mm-hmm. Yeah, I guess for a person like you, maybe working in data science is about the two aspects of it, the data aspect and the science aspect. For me, as I think I mentioned that before, for me, it's mostly the science aspect. And data is just the thing that allows me to do science. And I think that is good and bad. The good thing is that probably, I guess, data scientists that come from an academic background have stronger skills to solve complex problems, and they are not scared about getting analytical and going into the depths of a statistical discussion. Mm-hmm. So I think that's a positive aspect. And maybe even the solutions that a person that has been doing theoretical astrophysics can come up with are stronger or more complex than a solution that a person that has not had that background. On the other hand, maybe what academics lack, not maybe, I'm pretty much certain about it, is the ability to do good code, for example. Programming and using tools that are very common in industry, like, just using certain Python libraries, for example, or having certain standards of code cleanness, for example. In academia, that is not a thing. Like, you just have to write a paper or present some results in a conference, and you just have to have a result that you can show, or you can write down the solution, or the number that you wanna, or the plot that you wanna show to prove your point. It doesn't matter if the code that you wrote is very strong or very well documented, or if it would even run again if you executed the code again. It doesn't matter. You just have your result, and that's it. Whereas in industry, it's rather the opposite. You don't care so much about the solution, the number or the plot or whatever. You don't care so much about the final outcome, whether it's the optimal solution or whatever. You just want something that is good enough given some requirements. But what is more important is how you get to that, which is a code that has to be robust and has to probably be executed very often, if not every day or constantly online. Like that is more important. So whatever you do there is not just for you, it's for you and your team, and possibly for other people that are going to work in that company after you possibly leave, right? So whatever you do, if you want to actually be useful for the company, you have to document the code very well, which is in academia, you write a paper, but you don't necessarily document the code that you did to generate the results of that paper. But in industry, you actually have to do it because your colleague may not understand why you did things in a certain way. So that is a very big change from going from academia to industry, learning how to do decent code. I think it's probably one of the most important aspects.
Yeah, I guess it's very important also to, as you say, to make your code accessible for other people. Because when you actually start to work with the code from other people and you don't understand a thing there, this is really annoying. And you have to ask so many questions to one person, to another person, to the third person. So it saves so much time and so much energy to actually, to have more of it for other problems that the company might have. So very important. It's such a great point.
Yeah, and I think this can happen also in academia. Don't get me wrong. I'm not saying that there is no academics who can write good code. There are very good ones, of course. But just generally, it's not as required as it is in industry. That's all I'm saying. So that, at least for me, it was one of the biggest steps, the biggest learning curves that I had to go through to be better at writing code.
How did you actually learn data science? Did you study it or did you learn it by yourself?
Well, the research that I was doing was very strongly connected to data, which we were doing simulations, or we were also studying data from gravitational waves detectors or from radio telescopes. So my job was also getting your hands dirty with data in many occasions, although I was doing also theoretical work. But yeah, I already had a lot of experience dealing with data, but the tools were very different. And yeah, as I said, the standards of quality of code was different from industry. So, but I guess I had already a little bit of an advantage compared to someone who had done more purely theoretical, not data-driven research. And all research is data-driven in to a larger or smaller extent, but we really had big data problems to solve. We had a lot of data, so that already gave me a little bit of a boost in my data science career. But when I started looking for my first job, and in all interviews they were asking me about TensorFlow or Keras or things like that, I was like, yeah, I will learn about these things, definitely. I'm really interested, but I didn't know them. Like I just never had the chance to use them. So I just had to learn them. And one of the things that I did is online courses. I would go back to uni or doing a master in data science. I already had a PhD, and it felt like it would be probably unnecessary. And I think in my case, it worked out well. Like I was doing some online courses. I was also, doing some solving little problems on my own, like trying to see how things work, just trying out things and watching tutorials, reading blogs. That's the kind of thing that helped me a little bit just to start. But I think in the end, what helped me the most was to just start working, like to start to get my first job and learn the tools that they use. It took me a couple of months, but very quickly I was already like knowing what tools are used for what. Tools are things that you can just learn them. It's not a big deal. There are just many, but each one of them you can, for a particular project, you may need, if the project is related to computer vision, then you learn certain tools that are used for computer vision problems. If your problem is related to NLP, then you learn some other Python libraries or whatever tools that are accessible for you, and you just learn how to use them. So yeah, I learned some of the more theoretical aspects of data science from online courses, from reading some articles, blogs, and online material. But most of the things that I am able to use right now, most of my experience comes from actually doing things. So
from getting hands dirty.
Yes, exactly. Learning by doing.
Yeah, definitely. Sounds very interesting, and I guess this might be one very, very important advice for people who come from academia into business world. Is there anything else you would like to share for those kind of people with this kind of background? Anything that helped you so much, or maybe you would say it to yourself a couple of years ago and it would help you so much?
I think there are way too many things that I would tell myself.
Okay.
That's why I started writing a blog about this, because I think there's many things that would have helped me along the way to make this transition easier. The thing about the code is very important. Also, learning more how to use things like Git, to share your code with other people, and to make sure that whatever you do is consistent, that you're not going to step on the work that other person has done. Yeah, these kind of things are more like related to code. Apart from that, I think another aspect of academia that I have always felt that was lacking in my career was project management. Like, we had daily telecons and we had weekly meetings and things like that, but they were so inefficient. Like, I remember just being in endless teleconferences and online meetings with people from all around the world, or even with my own group, a very big group of people, and not saying a word, just listening to what other people are saying without really understanding, because it was not what I was working in at the moment. So somehow I feel now in retrospective that all those meetings were kind of pointless. I mean, it's not bad to learn what your colleagues are doing, but if you're not working in that topic at the moment, I think it may be better for you to use that time in something else.
Yeah.
So, now when you move to industry, you usually have very strict methodologies on how to work every day. You may have you may follow an agile methodology. You may have a Scrum Master. You may have to follow a Kanban board where you have some tasks in the backlog, sometimes tasks in to do, some others doing, some others in review, some others done. All these things. But I didn't used to do this in academia. Maybe some people do. In the groups that I have worked, that was not a big thing. So I think for me, a little bit of project management and how to be effective and how to try to aim at having early results as soon as possible. That is something that would be really valuable in academia. In the end, you have to write papers, and that's all you have to do. You have to just write papers, as many as you can. But how you get to those results that allow you to write papers, you can be much more efficient by following certain methodologies, and not just like, oh, I'm stuck in this problem, I'm just gonna keep thinking about it until I solve. That may not be the best way to spend your time. If you're blocked in a problem, move to something else. Try to do some other tasks that were left behind in a imaginary to-do list. Try to solve these little things that are giving you a little bit of value and may probably reveal the solution to the bigger problem. So these kind of project management sort of things are the second biggest recommendation I would give to academics moving to industry, to learn a bit more about that, how to be effective with your work.
Wow. Yeah, that makes so much sense to me now as well. So getting your hands dirty, learning about project management and methodologies like Agile or Scrum or Kanban. And the last thing that you say, I'm trying to get better at this right now. And there was a friend who gave me this advice to, when you start working on some project or task, try to complete the whole picture instead of moving like pixel by pixel and trying to make every pixel perfect. You know what I mean? So like it's so much better just to make things imperfect but done, and then if you still have time to work on particular parts of the whole project. This is such a game changer. No one ever told this to me in the university or in any online course, and it's actually so hard to practice this, because it's very, like, at least for me, it's very easy to put all the concentration in one little problem, like you say, neglecting all the other things that are just as important. So great advices. Thank you so much. I will also definitely share the blog that you're writing in our website and in the show notes in the description of the episode. And the last thing I wanted to talk with you about is, I know that it's not the first time where you use your data science skills for good, for a social or environmental cause. You told me that the other day about a project that you were doing, which is Data Science for Good, if I'm not mistaken. So I think it would be very valuable also if you shared your experience with that movement.
Yeah, so there is a summer school called Data Science for Social Good, but now I think there are like different chapters of it called DSSGX, as in, there is TED Talks and TEDx Talks. So I think now there are like different chapters of different organizations of Data Science for Social Good. The one that I did was in 2019 during the summer, and it was in England. It was organized by the Alan Turing Institute and the University of Warwick. And basically, the concept is that you have real problems that need a solution, and those problems are offered by our project partners, which could be NGOs or government institutions, they need a solution for a certain problem that can be solved during duration of the summer.
Mm-hmm.
And then you have the data scientists that are going to solve these problems. These data scientists are not necessarily people that are already professionally working on it, but they may be students as well. So it's a mix of people with academic backgrounds and also industry background. It could be students, it could be people that are already working as data scientists. It could be a mix of them. And what we do during the summer school is we teach data science. Well, me as a technical mentor, I was working as a technical mentor, not as a fellow. But yeah, so what we did was to, part of the time we were teaching data science tools or like Python or libraries like pandas and things like that. Also how to do model selection, how to decide about metrics, or a very important topic is bias and fairness of machine learning models. That's a massive topic when you are working in social issues or environmental issues. It's more important than if you work in, I don't know, e-commerce companies. Also that, like, it's always important, but for some projects it's more important than others. So yeah, part of the summer school was to teach about data scientists, and part of it was to actually solve a problem within 3 months.
Nice.
So the summer fellows were extremely talented and motivated people from all over the world, from top-notch universities, from big companies as well. Like, they were really smart people and really motivated to solve problems that actually matter. And so what we did during the length of the summer was, apart from teaching some of these things, was, for example, work with Cochrane, which is it's an institution that writes medical reviews. So basically, you have a lot of medical papers being published every day. And what they do is to generate reviews that in the end are read by decision makers in medicine. Because, your doctor, when you go to a doctor, they can't keep up with research. They cannot read all the thousands of papers that are published every day, but maybe they follow some guidelines written by organizations that write reviews, or they are more aware of the literature, and they take some conclusions on what's the latest about heart diseases or about diabetes or whatever. So yeah, Cochrane that generates these sort of reviews, and to do that, they have people that are basically reading papers and extracting the good ones and from the bad ones and generating these reviews. So what we developed was a tool to classify papers into different categories and decide which ones are definitely relevant, and for those papers that were sort of in between, we were like, the model doesn't know here, a human has to supervise and decide. Right. And these sort of hybrid solutions, I have realized that's one of the main things I learned in the summer school. Those are really important and useful solutions. You don't want to have a purely AI-based solution, and you don't want to have a just human-based solution, because simply that's inefficient. That may take a long time. But having something in between that, it solves part of the problem automatically, but for the range where your machine learning model is not capable of solving, for that sort of gray area in between, then you let a human solve that problem. So that's, in a nutshell, that's the solution that we proposed and that we actually developed. So it's a classifier that gets reads papers that are uploaded into a database, and it decides which ones are definitely worth for a certain type of review and which ones are certainly not relevant. And for all of them in between, then, a human has to review them. So for those people that are doing the reviews, we are saving them an important fraction of their time, because these papers, they don't have to read them because we already told them that they're sort of pointless. They're not related to that topic. Yeah. So that was one of the projects we worked on. And there were many other projects related to, for example, poverty. There is an app in the UK where you can report if a person is if you find a person in the street, so that you can call help services to help that person. So one of the teams was working on improving how this app works. So, for example, if a person is found in a very crowded area, many people are reporting the same person. So, it's important to find duplicates and to make the app work more efficiently, so that more people can get helped, and to save the time of those people that go out there and help actual people. We want to spare their time when they are doing things that are not necessary. We want them to help the largest amount of people possible. That was another project. Another project we worked on was with an institution of Paraguay, which what they do is to detect fraudulent public procurement processes. So we did a lot of natural language processing, so that they can detect which public procurements were, illegal or possibly connected in one or another way to some fraudulent process. So those are some of the projects that we were working on. And overall, I think it was a really tough experience. It was a lot of work, but it was positive. Like I learned a lot, and I think it's a great experience. If you can apply as a fellow, it's really a great experience. It will be tough, but you will learn a lot. And I think that you can be sure that the work that you're doing has, it produces something in the end. At the end of these 3 months, you have to be sure that you have a data product that your project partner is going to use. So, you know that whatever work you're doing, and it's very hard, that in the end, that's going to be used and do good.
Oh, yeah. Yeah, so interesting, the projects that you were telling me about right now. And actually, it seems like the perfect opportunity for those who want to transition from academia into a more practical commercial world, to have a real experience on top of using those libraries that you said that sometimes are neglected. So really nice. I will definitely leave the link in the description as well.
Yeah.
And well, we're running out of time, so this is your opportunity, the moment of glory, so to say, to share your contacts. You can share anything you feel like sharing. If you have any problem that you would need help with, feel free.
Okay. Well, if you want to talk to me, or if you want to learn a bit more about me, or if you want to read the blog that I'm writing, I have a website, pablorosado.com. You can visit that, and I also have some music content and video content as well, if you're interested. And
Nice.
Otherwise, if you want to connect in LinkedIn, I'm also there. I'm available. So just write me a line, and I think that's
cool.
That's it.
Nice. All those things, as I said, there will be. You can find them on our website or in the description. So thanks a lot, Pablo. It was a great pleasure to have you here today, and nice talking to you. Thank you a lot.
Yeah, thank you very much. It was very interesting. Thank you.